I am Billy Lara, and I'm here to present the study of Takagi, Sugimoto, Nishijima, and Wilson, entitled The Differences in Stroke Phases, Arm-Leg Coordination, and Velocity Fluctuation due to Event, Gender, Sex, and Performance Level in Breaststroke. In the introduction, I'll discuss the background of the main topic, the problem faced by previous studies about it, and the purpose of this study. So, breaststroke is one of the four major competitive strokes in swimming. It has been studied numerous times due to its unorthodox nature as compared to different strokes. It is characterized by the discontinuous propulsion and dependence of proper timing. Studies show that experts adjust. By experts, I mean competitive swimmers specializing in breaststroke, how they deal with these technical mechanical issues. These include combining high velocity with long strokes, adjusting arm and leg patterns and tempos based on distance of events, and emphasis on arm leg coordination. The problem with previous studies is that they were one-dimensional. One-dimensional in the sense that there are no descriptions of variations between events, sex, and performance levels. The studies were all focused on a select few individuals. Also, the environment in the studies were too controlled. They were done in a training setting, when in reality, real racing performance behaviors differ than actual competition. There's external factors such as adrenaline tapering, pressure, that make or break a person's actual swim, which you can only see in actual competitions. Having said that, the purpose of this study is to compare variations in stroke phases, arm-leg coordination, and intracycle hip velocity fluctuation between events, sex or gender, and performance. In the methods part, I'll discuss the participants, define some terms, and discuss the research protocol and methods used. The participants were taken from the 2001 FINA World Championships, FINA being the governing swimming body, and the World Championships are basically the Olympics of swimming. Male and females were taken into account for the gender or sex variable. They were in lane. All swimmers were in lane 4 to 5 in every preliminary round, semifinal, and heat and finals to get the performance level and to get the difference in the event variable, the 50, 100, and 200-meter breaststroke were taken into account. So this is lane 4 and 5, the two fastest swimmers per heat. So to have a better understanding of the technicalities of breaststroke, the researchers first defined a few terms, which I'll discuss as well. First, the stroke phases of the arm, which has been before. The recovery is the period of maximum flexion of elbows under the breast. The glide is when the arms are completely outstretched and forward. The outsweep is when the first lateral movement of hands until the first down and backward movement. The insweep is the end of the outsweep until hands come together for recovery. The legs also have phases 3, namely the sweep, which is the maximum dorsiflexion of ankle to maximum extension of knee when feet come together. The lift and glide, which is the end of sweep until legs are in line with the body. And the recovery, which is the first forward movement of feet by flexing knees to maximum flexion. These stroke phases for both arms and legs are important in determining the difference in stroke phase in general between variables. The SRT is a non-propulsive phase is when a non-propulsive phase is exhibited. The ALT is the start of the arm and leg propulsion divided by the duration of the stroke. The SPT is when a phase of simultaneous arm and leg propulsion is exhibited. A non-propulsive phase consists of the glide and recovery. The SR means the stroke rate, the number of strokes. The SL means the stroke length, the length of each stroke, and V is the velocity. Research protocol. Both separate and simultaneous arm and leg motions were calculated as measures of arm-leg coordination. The SRT, ALT, and SPT are all expressed in percentage. 3 underwater cameras were used with separate views. So they were put in lanes 2, 4, and 5 underwater. Lane 2 for the side view, this is what you would see. They're focusing on lane 4 and 5, and this is what the cameras on the lane 4 and 5 themselves would be. They were looking at the below each swimmer directly. So the mean intracycle horizontal hip velocity was calculated by gender, sex, event, and performance level, and the data was used from the stroke cycles of the first 25 meters of each race, because as the race progresses, fatigue comes into play, and it drastically changes how a person swims. Results and discussions. So first we have the findings of the difference in sex and gender. As you can see, the SL and V were higher in males and females. This can be associated with the anatomical differences between the two sexes. Additional findings show that SL and S are inversely proportional for both sexes, meaning the higher the stroke rate and the lower the stroke length, etc., and vice versa. Um, the SR did not have significant variation between the two sexes. For the event variable, it is seen that the sprint event, 50, involves a higher stroke rate and velocity, while the distant event, the 200, involves longer strokes. This makes sense because the sprint events require speed and a higher stroke rate and power, explosive power, while distance events require longer strokes to preserve energy for the entire race. Additional findings include the percent ALT, SRT, and SPT were significantly different per event. The longer the event, the higher the percent ALT and SRT, while vice versa for SPT. This is because the longer distances require more non-propulsive action, such as the glide and recovery, which is why the stroke length of distance events are longer. The performance level variable was very similar to the results of the variable of sex and gender. The SL and V were higher in the finalists than non-finalists because it could be deduced that the finalists are faster, since they got into finals, and have better technique enabling their longer and more efficient strokes. The intracycle hip velocity fluctuation analysis. So, the non-propulsive phase is key for efficiency. It's recommended for breaststrokers to learn to minimize the fluctuations of intracycle velocity due to energy expenditure. More elite swimmers experience less reduction in velocity during non-propulsive phase. Conclusion and implications. Regarding the events, the difference lies in the changes in arm recovery and glide phases. Better performance can be attributed to changes made in technique to decrease hip velocity. The study provides concrete material for training programs all over the world to use. This means that you can use the findings in the study for all sorts of training programs, such as grassroots, collegiate, or professional. Adding a scientific element to sports gives athletes more opportunities for improvement. It could be the key to unlocking an athlete's true potential. Stroke technique correction can be implemented based on the findings of the study. Self-explanatory. Strength and conditioning coaches can adjust their programs for breaststrokers' needs, meaning the target muscle group, the quads, glutes, all important for breaststrokers. Training programs can be drastically altered based on event distance. So not just in strength and conditioning, but training programs in general can be structured with regards to mileage, intensity, and duration for based on the event, 50, 100, 200.